So in R.3, we're going to talk about exponents, roots, and orders of operations. So the first objective is talking about exponents. So just to make sure we're all on the same page, exponents are just a way of writing products of repeating factors. And so for instance, if you had 2 times 2 times 2 times 2 times 2, I'm way too lazy to write that. So instead, mathematicians came up with a way to write it simpler. So they go, okay, my base is 2. That's the number that I'm multiplying together. And how many times do I want to multiply it together? 5. So now anytime you see something written like this, you know that it's 2 multiplied by itself 5 times. We call these things powers. So 2 to the exponent 5 is a power, where 2 is the base, it's the number getting multiplied by itself, and 5 is the exponent. You can read it as 2 to the exponent 5, you could read it as 2 to the 5th power, or 2 to the 5th. There's 2 special cases that we say a little bit differently. So in other words, if you have 3 to the exponent 2, we don't read it as 3 to the 2nd power, we read it as 3 squared. And the reason is because squared is the units for area. So it's 3 times 3 and it makes a square. So we call it 3 squared. Same thing with 3 to the exponent 3. We call it 3 cubed because we would go the volume of a cube. So length times width times height. So length times width times height is a cubic measurement. And so we call it 3 cubed. And it just became sort of the nomenclature that we use. All right, so the first thing is simple. I just want you to write things in expanded form and then evaluate. So understanding that 5 squared is 5 times 5, right? And then evaluating means performing the operations. So 5 times 5 is 25. If I have 2/3 to the exponent 3, my base is 2/3. So it's 2/3 multiplying by itself 3 times. Now we haven't done one like this yet. When you have more than one fraction multiplying together, you still just multiply across. This would be 2 times 2 times 2, which is 8, over 3 times 3 times 3, which is 27. All right, the next thing is just a caution. Really, it's the only thing you got to be careful with is we're going to be talking about integers and rational numbers. And so there's going to be positives and negatives. And people always get confused with the difference between -2 to the 4 and -2 to the 4. And half the time when you plug it into your calculator, unless you really know what you're doing, your calculator will give you the wrong answer because your calculator will assume things. So what I want you to pay attention with this one is that what's the base versus in this one, what's the base? So in this one, the exponent is touching the bracket. So anything in the bracket is to the exponent 4. So this would be bracket -2 times bracket -2 times bracket -2 times bracket -2. Because it's an exponent 4 touching the bracket, the entire bracket gets multiplied together. So we've got a negative times a negative, which is a positive, times a negative, which is a negative, times a negative, which is positive. So I know that this is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. This is positive 16. Whereas this one, the exponent is only touching the 2. So this would be -1 times 2 times 2 times 2 times 2. The negative is not, the exponent is not being applied to the negative. So this answer is going to be negative 2 times 2 times 2 times 2, which is -16. Now try those in your calculator. You know, if you plug this in, will your calculator give you positive 16? If you plug this one, will your calculator also give you positive 16? So a lot of people's calculators, and mine included, it won't let me do this second example. This one, it won't let me plug that in because as soon as I hit -2 to the exponent, it puts the brackets there. It's like, well, I know what you want. It's like, no, that's not what I want. Now, if it was in a calculation and you were subtracting, that's different. But if you try to type -2 to the 4, it will usually automatically put your brackets on for you. Okay, and then this next one, so what's the difference? Well, this one would be -2 times -2 times -2. So negative times a negative is positive, times a negative is a -8. Whereas this one would be -1 times 2 times 2 times 2, which would give me -8. So both of these give me the same answer, so your calculator won't give you a signal whether you're doing it right or wrong. So just be careful. But what I wanted to show you here is that when you have a negative number raised to an even exponent, then the answer will come out positive. So this reads the product of an even number of negative factors. So when you have an even exponent of a negative factor, it comes out positive. But when you have the product of an odd number of negative factors, like a 3, then it comes out negative. just so that you don't have to do that whole a negative times a negative is a positive, like that just gets annoying. So just know if it's an even exponent, it comes out positive, unless the negative is not in the bracket. And if it is an odd number, then it comes out negative. All right, so that should prep you for doing the exponents section.